Welcome to Section 3, Stormwater Inspections and Maintenance. In this section, I will explain how to conduct a self-inspection and plan for stormwater facility maintenance to stay in line with your legal requirements as an HOA. This is the core of your stormwater responsibility. If you are watching this section separately, having skipped the other training sections, we strongly recommend that you view the other sections later to ensure you have a basic understanding of stormwater and your legal responsibilities for stormwater management. By the end of this section, you should be able to read your HOA's engineering plans to assist in locating stormwater facilities in your neighborhood and identify commonly used facilities and assess their maintenance needs on site. You should also be able to plan for good housekeeping and maintenance activities, including determining what maintenance you can do yourself or identifying when to use contractors. You will also learn how to plan for maintenance and replacement costs. This is the longest section and will take approximately 1 hour to complete. However, you do not have to complete this in one sitting. Following a brief introduction, this section has been broken into 3 main subsections: preparing for inspections, inspecting BMPs, and housekeeping and maintenance. This allows you to go through the content in smaller chunks if needed. There are also navigation tags in the video to allow you to find the information you need. A PDF of the materials is also available for reference. Let's get started. Note that self-inspections are a part of maintenance, since you cannot address maintenance problems that you don't know exist. How often to inspect your stormwater facilities is outlined in your Operations and Maintenance Manual if your plat has one. Some plats may not have this. However, if you inspect once per year, you will be able to address any concerns in a timely manner. The inspection should take place when it is dry so that you can see all of the features and potential problems. If possible, it is also strongly recommended to inspect after a major storm event, which is any event resulting in 1.2 inches of rain or more in a 24-hour period. Note this is called the 2-year 24-hour storm. Most stormwater facilities are designed per the Stormwater Management Manual for Eastern Washington to handle this size storm without problems. Such an inspection provides you with an opportunity to visually check for any problems with stormwater flow, such as reduced infiltration, overflowing, or blockages, especially if your annual visual inspection is done during a dry period. During an inspection, it is helpful to have a copy of your site plan to help you find each facility. If you have a clean copy with you each time, you can highlight problem areas noted during the inspection. As you inspect each facility, focus on how it should work and schedule any maintenance needed so that it can function as intended. We'll go over examples of this later in the training. Finally, share information with your HOA members or neighborhood residents regarding your stormwater system and ask them to report any drainage problems so that they can be addressed immediately. Stormwater facilities are an investment that can save your HOA money in the long term if they are managed appropriately. Do not let your HOA's money go down the drain by neglecting them. Regular inspections and maintenance will equate to savings for your HOA, and the time spent inspecting and maintaining your stormwater facilities will be well worth it. Inspection and maintenance will help save money by reducing high-cost, non-emergency fixes due to neglect, expensive emergency fixes due to failure, and additional costs associated with poor drainage or flooding from neglected or failed stormwater facilities. This could include property damage or the need to repair roads and other infrastructure. In addition, county inspections are also less likely to identify any maintenance requiring a compliance timeline, which can reduce county tax dollars spent on inspections and follow-up. Self-inspections start on paper, but there may be several types of documents available to you online. These include plats, engineering plans, as-built, and road and drainage plans. Plats show the legal layout of the development, such as your subdivision, and include the plat dedication. Engineering plans are the plans that guided construction of the development. As-built are the engineering plans that show the final constructed conditions, as there may have been changes made during construction. Road and drainage plans show the road design and drainage features of the development. Before we look at an example engineering plan, here are some tips on reading and understanding your own HOA's neighborhood plans. First, know that engineering plans are standardized, meaning the information is pretty similar across different plans. Since this is an online training, you might want to take time to pause the video to print your HOA's plans so that you can identify the same elements in your plan as the example we will use in a moment. Secondly, like a map, plan sets will typically include a north arrow to help orient you. Also, like some maps, engineering plans are line drawings that represent features on the ground. If needed, you can use an aerial photo to assist you in connecting the plans to reality. For example, you can use Google Maps, Google Earth, or Spokane County Scout Map to get an aerial view of your area. Lastly, once you feel that you understand your plans on paper, get out and walk around your HOA's neighborhood with the plans in hand. Familiarize yourself with the stormwater facilities before doing a more thorough inspection. If you are having a difficult time relating the plans to actual features, think about where the water will go when it rains and try to trace its steps. If you do this, you will get a sense of how the different stormwater facilities in your system are connected as you find them. During this time, it might also be helpful to ground truth the plans in preparation for an inspection. This is important because the plan sets, even as built, may not always match what exists. In some cases, features that were planned were never built, and vice versa. You may want to note where there are differences. If you follow these steps before completing a self-inspection, you will have fewer surprises and less frustration because you will be prepared. Let's now look at an example plan and learn how to read the engineering drawings. Before I show an example engineering plan set, I wanted to start here on Spokane County's webpage for homeowners associations. This is where you can locate and download your homeowners association's engineering plan set. You can use these tabs to find the name of your homeowners association by alphabetical order, and then you can find the engineering plans to the right. If you have difficulty finding your engineering plan sets, you can contact the stormwater staff at the number shown, and they can help you either locate those documents on the webpage, or maybe they have something available that's not online. You may want to take a moment and pause here to locate your engineering plan set, or if you rather, you could start with me on the example that I'm going to use, which is Alderwood Estates. I'm going to look at the Alderwood Estates as built, since that should show the current existing conditions on the ground. We will go to that example next. I have opened up the Alderwood HOA as-built engineering plan set. Each plan set will start with a cover sheet that looks like this and have several of the same elements no matter what the plan set is. There will always be the title of the project at the top, which for here is Alderwood Road and Drainage Improvements. As-built will also usually have a stamp indicating that it is an as-built. Cover sheets will usually provide a vicinity map showing where the project is located and a more detailed drawing showing the extent of the project and what it entails. There will also be a north-south arrow to show you the orientation of these maps and a scale to give you a sense of the size. Each cover sheet will also have a sheet index indicating the number of sheets in the engineering plan set as well as their names. And there will also be a legend describing all of the symbols used in the engineering drawings. If you look more closely at the legend, you can see examples of all of the stormwater features that you will locate in your engineering drawings. I'm going to zoom in here. For example, you will see stormwater swales and ponds, which are shaded areas that look like this. There are also storm drain lines, indicated by a dark line with SD in the middle. There are storm drain manholes, indicated with a circle with a SD, and dry wells, which are indicated with a circle with a D. You can also get a sense of where your stormwater features are in the plan set by looking at your sheet index. There are several sheets that have the plan and profile of the individual roads included in the project. We're going to look at sheet 5, Onic Lane Plan and Profile, as an example. There is also on sheet 8, 208 Swale and Detention Pond detail sheet that describes all of the stormwater swales and detention ponds. So we'll take a look at that as well. You can tell what sheet you are on over here on the side in the title block. Right now we are on the cover and index sheets, and we'll go to the detail sheets next. This is an example of a road design sheet for the Alderwood Estates plan set. As you can see, we are on sheet 5 of 11, and the title block indicates this is for Onic Lane and shows the plan and profile drawings. The plan drawings provides an overhead view and is here on the bottom of the sheet. The profile drawings provide a cross-sectional view and is here at the top of the sheet. The placement of the plan and profile drawings on a page may vary, even within the same engineering plan. Although this sheet is primarily to show the road's design, the road plan drawing and the north arrow can help you orient yourself and find stormwater features. If you look closely, you can see where stormwater features are located along Onic Lane in the plan drawing. Give me a moment to zoom in to show you. You can identify stormwater features by matching the notes with the feature's location by their number. For example, number 2 is a catch basin and is shown here on the plan set right about where the road turns on the south side of the road. You can also note that there are detention ponds at item 24 and item 26. Item 24 is shown here between lots 11 and 12. Item 26, detention pond, is shown here at the end of Onic Lane. So you can see how this can help you locate stormwater facilities. It's worth noting that to save space, a single note can be used for multiple features in the drawing. However, you can always double check to see if there are individual items like more catch basins that are indicated by different numbers. If this is still not helping you identify where stormwater features are, you can always use this to help orient you with an aerial photo such as that on Google Maps. For example, I have pulled up Onic Lane on Google Maps, and when I zoom in, I can see that the stormwater features between two properties is located here, as shown in the drawings. At the end of Onic Lane, there was also another stormwater feature which appears to be here. So you can see how the plan sets help you orient yourself to what is on the ground. This is an example of a plan sheet dedicated to the design of stormwater features constructed as part of the Alderwood HOA. Notice that we are on sheet 8 of 11 and that it is for the swales and detention ponds. The labels of each of these features can help you connect it to a location in the road design sheets that we were looking at before. For example, this feature here, Detention Pond H, is on the road design sheet for Onic Lane. Let's go back to that sheet for a moment to find it. If you look here at item 24, between these two lots, we can see that item 24 was for Detention Pond H. These detailed sheets are helpful for stormwater management because it provides specific information important to the operation and maintenance of each facility, including but not limited to its size and water storage capacity, its design features such as the side slopes, inlets and outlets, safety features such as fences, and maintenance access roads and any access easements. Let's take a look at Detention Pond H more closely as an example. Give me a moment while I zoom in. So Detention Pond H is indicated with Note 8. Note 8 at Detention Pond H provides a few detailed information for this pond. For example, the top of the berm's elevation is 2053. The bottom elevation is 2051.33. The bottom area is 1320 square feet. The depth is 5 feet. And the maximum surface elevation for the water is 2051.99, which is the 50-year storm. You can also note that there is a dry well as an outlet feature. This feature here is noted by note number 9, which says that it's a 12-foot wide gravel access road. You can also note that there is a catch basin connected to a storm drain pipe, which leads into the detention pond. You can also note that there is a fence around the detention pond. So when you go to inspect, you should be looking for all of these features and that they are operating correctly. Let's take a look at another example. We're going to scroll up here to Detention Pond F. This too was on Onic Lane. Let's go see if we can find it on the road plan. Remember, number 26 was a detention pond, and this is Detention Pond F. So we have located it at the end of Onic Lane. Going back to the details, we can see that there are some pipes going into the pond on either end. There is also a fence around this pond. And if we want some details about how it was designed, we can look at note number 6. We scroll down. Note number 6 provides some elevations that we can look at. Scrolling back up, we can also see note number 9 is repeated here, meaning that this too has a 12-foot wide gravel access road. Again, these are the features that you want to make sure are in place and operating correctly when you inspect this feature. Hopefully, this gives you some confidence when you are reading these plans and when you go to inspect your own HOA's stormwater facilities. Now that you understand engineering plans, let's go over the common stormwater facilities used in the Spokane area so that you know what to look for during an inspection. There are two main types of facilities, those on the surface and those that are underground. Surface facilities common in Spokane include infiltration swales, bioretention facilities, various types of stormwater ponds, ditches, and culverts. Underground facilities include catch basins, oil and water separators, filters, and dry wells. In many cases, stormwater pipes will connect a series of catch basins or connect a catch basin to other stormwater features. There may also be maintenance junctions to access the underground facilities. While we will go over each of these facilities and a few common things to look for during an inspection, Appendix 6A in the Stormwater Management Manual for Eastern Washington provides a table of all maintenance routines for each stormwater facility that should be used during an inspection. These are available online for convenience. Ditches are a form of stormwater conveyance that are typically located along a road. They are usually V-shaped open channels meant to convey stormwater quickly away from paved surfaces to prevent flooding. Therefore, they do not provide any treatment of stormwater. Ditches will route and discharge stormwater to a storage feature, such as an infiltration pond, or the water can be dispersed as sheet flow. Ditches can be made of rock or vegetated embankments, such as the one shown here. Inspecting ditches, check for conditions that could cause structural problems to the ditch or impact its ability to convey stormwater effectively. This includes erosion or scouring from fast-moving water, burrowing from animals, or human activities such as foot traffic. Sediment buildup that reduces the ditch's capacity or alters the grade such that water flow is affected. Potential indicators could be more than 2 inches of sediment buildup or standing water that lasts more than 48 hours after a storm. The ditch should also be clean and free of any leaf litter, grass clippings, pet waste, or other debris or pollutants. Infiltration swales are grassed or rock depressions that receive water from paved surfaces. Like ditches, these are usually located along a road or sidewalk. Unlike ditches, they usually have a flat bottom and a slope of less than 1%. Rather than being a conveyance structure, swales are intended for infiltration. It should be noted that grassy swales are preferred and rock swales are generally discouraged. Depending on the size, there may be one or more inlets that direct the water into the swale. Inlets can be concrete pads, rock structures, or pipes. While the grass in the swale is intended to slow the flow of stormwater, it should not impede its movement through the swale. The grade of the swale bottom allows for stormwater to spread throughout the area as it enters the swale. The soil used in swales allows for stormwater to infiltrate into the ground and filter out pollutants. In many cases, there will be an outlet structure, such as a dry well or catch basin, that sits about 6 inches or higher than the bottom of the swale. This prevents overflow if the swale fills to capacity during large storm events. When inspecting grassy infiltration swales, first check for healthy, low-cut grass with minimal bare spots. In most cases, you would want 90% coverage. Then check for conditions that could cause structural problems or impact the swale's ability to filter stormwater effectively, such as erosion or scouring from fast-moving water or other disturbances such as foot traffic, sediment accumulation with no more than 2 inches of sediment buildup and no standing water 72 hours after a storm, blockages at the inlet or outlet structure from sediment, litter, or debris. Note that it is not enough to have a clean or open inlet or outlet structure. If sediment is built up around the inlet and impedes flow, this can cause problems such as water backing up into the road. If sediment builds up around the outlet, water may leave the swale more quickly. Structural problems at the inlet or outlet include any damage, settling, or misalignment that could disrupt its function. For example, the outlet structure, whether a dry well or catch basin, should be 6 inches above the bottom of the swale. The swale should also be clean and free of any leaf litter, grass clippings, pet waste, and other debris or pollutants. Inspecting rock infiltration swales is the same as inspecting grassy infiltration swales. Check for conditions that could cause structural problems or impact the swale's ability to filter stormwater effectively. This includes similar problems such as erosion or scouring from fast-moving water or other disturbances such as foot traffic, 2 inches of sediment buildup and no standing water 72 hours after a storm, blockages at the inlet or outlet structure from sediment, litter, or debris. Again, note that it is not enough to have a clean or open inlet or outlet structure. If sediment buildup around the inlet impedes flow, this can cause problems such as water backing up into the road. If sediment builds up around the outlet, water may leave the swale more quickly. Structural problems at the inlet or outlet include any damage, settling, or misalignment that could disrupt function. For example, the outlet structure, whether a dry well or catch basin, should be 6 inches above the bottom of the swale. The swale should also be clean and free of any leaf litter, grass clippings, pet waste, or other debris or pollutants. The next stormwater feature is bioretention area. A bioretention area are vegetated depressions with a mix of plants grown in soil and mulch overlaying a gravel bed with perforated underdrain. These are sometimes called rain gardens. They are usually located along a road or sidewalk. The plants and soils are selected to hold stormwater in a slightly ponded condition, usually 6 to 12 inches, to retain pollutants as the stormwater slowly infiltrates into the ground. It is worth noting that there are very few bioretention areas in Spokane County, especially in neighborhoods that are older than 10 years. When inspecting bioretention areas, first check for healthy plants that are not too sparse or overgrown. Then check for indications of other problems, such as erosion or scouring of the mulch or soil. Note that there should be 1 to 3 inches of mulch protecting the underlying soil. There should be minimal sediment accumulation with no more than 2 inches of sediment buildup. And although bioretention areas help pond water for slow infiltration, there should be no standing water 72 hours after a storm. There should be no blockages at the inlet from sediment, litter, or debris. And check for structural problems at the inlet or curbs, including any damage, settling, misalignment that could disrupt function. The next stormwater facility we'll discuss is stormwater ponds. But before discussing individual types of stormwater ponds, we'll cover a few general things that they all have in common. All stormwater ponds are used when swales are too small to handle the volume of stormwater generated from the paved surfaces. They are built by excavating the ground, constructing above-ground berms, or both, depending on site conditions. They are usually fed by an inlet pipe or culvert. Due to their size, stormwater ponds are usually located on a dedicated piece of property owned by the HOA with a dedicated access for maintenance. In many cases, stormwater ponds are fenced in for safety. There are two types of stormwater ponds. Dry ponds, which are typically dry except for right after a rain or snow melt event, and wet ponds, which retain stormwater in a relatively permanent pond. When inspecting stormwater ponds, check that there is no erosion or scouring of the side slopes or berms from water, burrowing animals, or human activities such as foot traffic, bikes, or ATVs. Note that dry ponds may suffer more from disturbance, especially from human activities. There should be minimal sediment accumulation to prevent reduction in the pond's capacity. Note that this will differ by pond type, which we will cover in more detail. There should also be no excessive plant growth that reduces the capacity of the pond. Again, this differs for dry ponds and wet ponds, and we'll cover this in more detail. The area should also be clean and free of any leaf litter, grass clippings, pet waste, and other debris. You should also check any associated inlet and outlet structure. Again, we'll cover these associated structures separately. An infiltration pond is a type of dry pond that is specifically designed to allow stormwater to pond temporarily and infiltrate into the ground, much like a swale. For this reason, infiltration ponds will typically be dry and usually seeded with grass to function like a field, except immediately following rain or snow melt events when they become filled. When inspecting infiltration ponds, check for all the general requirements that we talked about before, keeping in mind that infiltration ponds only have an inlet structure but no outlet structure because it allows stormwater to infiltrate into the ground. As a type of dry pond, excessive plant growth that can reduce capacity includes grass over 10 inches or the appearance of shrubs or trees. Again, there should be no more than 2 inches of sediment buildup, and there should be no ponding or standing water 72 hours after a storm. If ponding becomes an issue, excessive growth of water-loving plants such as cattails may start to appear. Infiltration ponds must also have a percolation test every 2 to 5 years to ensure the water continues infiltrating at a rate that will not cause problems such as flooding. If you're unsure when the last percolation test was done, schedule one and then maintain the test schedule. Detention ponds are another type of dry pond that is specifically designed to allow stormwater to pond temporarily and then slowly release it through an outlet or control structure. In Spokane County, usually one or more dry wells are placed in a detention pond to serve as an outlet. Like infiltration ponds, detention ponds will typically be dry and usually seeded with grass to function like a field, except immediately following rain or a snowmelt event when they become filled. When inspecting detention ponds, again check all of the general requirements we discussed before, keeping in mind that detention ponds have both an inlet and outlet structure. The inlet is usually a pipe or culvert, and the outlet is usually a dry well. As a type of dry pond, excessive plant growth that can reduce capacity includes grass over 10 inches or the appearance of shrubs or trees. Again, there should be minimal sediment accumulation with no more than 2 inches of sediment buildup. Also, there should be no standing water or ponding 72 hours after a storm. Again, if ponding becomes an issue, excessive growth of water-loving plants may start to appear. Evaporation ponds are a type of wet pond that retains stormwater in a relatively permanent pond that can go dry depending on conditions. A pond liner or native soil such as clay act as a barrier for infiltration and hold stormwater in the pond. Since these ponds are designed to promote evaporation, they will be shallow with a wide surface area, and the pollutants are retained as the water evaporates. While these ponds will not generally have an outlet for the water, there may be an emergency spillway to direct overflow in the event the pond overfills during a large rain event. When inspecting evaporation ponds, check all of the general requirements we discussed before, keeping in mind that evaporation ponds have only an inlet structure but no outlet structure unless there is an emergency spillway. You should not be able to see the pond liner if one was used when walking the perimeter of the pond. There should be minimal sediment buildup, with accumulated sediment being no more than 10% of the design depth. Plant growth that could reduce the pond's capacity includes cattails and other pond vegetation. The plants will start closer to the edges of the pond and then move towards the center as they trap and accumulate sediment. There are a variety of inlet structures that are used in association with the surface stormwater facilities we've just discussed. These inlet structures include curb cuts, sidewalk under drains, and pipes or culverts of varying sizes and materials. Curb cuts and sidewalk underdrains are typically associated with swales and bioretention facilities. Pipes or culverts are typically associated with stormwater ponds. Inlets are used to direct stormwater into a surface facility. In some cases, pipes or culverts may be used to connect a series of swales or ditches by passing the stormwater under a driveway or road. Some inlets may open onto a rock splash pad that dissipates the flow to reduce erosion as the stormwater enters the facility. When inspecting associated inlets, check for problems that would prevent the inlet from effectively moving stormwater into the facility. There should be no blockages at the inlets from sediment buildup, leaf litter, pine needles, debris, or plant growth. In winter, snow and ice may also be problematic. Remember that blockages don't have to be right at the openings on either side, but can also occur within the inlet structure where it is not immediately noticeable. If water can't move freely through the structure, or if water is backing up, there may be a blockage. It is not enough to have a clean or open inlet structure. Blockages can also occur near the inlet, so check around the inlet as well. If sediment, debris, plant growth, snow, or ice are built up near the inlet in a manner that impedes flow into or out of the inlet, this can also cause a problem, such as backing the water up onto the road. There should also be no structural problems with the inlet. This may include damage, settling, or misalignment that could disrupt its function. The splash pad, if there is one, should also be intact without missing rocks or plant growth. All inlets should also be checked for evidence of illegal dumping. If you do see evidence of illegal dumping, you should report this to either the county or ecology, depending on the location. We'll cover this in more detail later. The catch basin, also called a storm drain, is probably the most recognizable stormwater inlet structure. They are typically located along a curb or in low points of paved areas. The opening is covered by a grate which keeps out large debris. Underneath the grate is a concrete basin that allows sediment to settle out of the water. Stormwater pipes can connect a series of catch basins, but ultimately the pipes route the stormwater to a discharge point, which, in Spokane County, is typically a dry well or swale. However, in some cases, catch basins and pipes may route stormwater to a surface feature such as a bioretention area or pond. Some catch basins may be fitted with an oil water separator or filter to reduce chemical contaminants. We'll discuss these separately at a later time. Like other inlets, when inspecting a catch basin, check for problems that can impede the catch basin's conveyance of stormwater flow. There should be no blockages at the grate from sediment, litter, leaves, pine needles, plant growth, or other debris. In winter, snow and ice may also be problematic. There should be no structural problems at the inlet or curbs, including any damage, settling, or misalignment that could disrupt its function. There should be no sediment buildup in the catch basin sump. Sediment should be no more than 6 inches from the outlet pipe. Check for any evidence of illegal dumping directly down the storm drain. If you do see evidence of illegal dumping, you should report this to either Spokane County or ecology, depending on the location. Again, we'll cover this in more detail later. Oil and water separators do exactly what their name implies. They separate oil and other floating chemicals such as grease from the stormwater by trapping these on the surface of the water that is inside the catch basin. Oil and water separators vary from simple to complex designs. Those most common in residential areas are relatively simple and might include a downturn pipe on the catch basin outlet pipe as shown here in this figure. Others may have coalescing plates, which are wavy edge metal sheets installed near the top of the catch basin. These plates help keep oil separate from the water at the surface so that it can be skimmed off. Though the use of these plates are rare in Spokane County, you will see an example of these on the next slide. Inspection of an oil and water separator should begin with the catch basin itself, since problems with the catch basin could impact the oil and water separator. Then check for structural problems at the outlet pipe that serves as a trap for the oil, including any damage or misalignment that could disrupt its function. If there is an oil layer on the surface, it should be less than 1 inch thick. Thicker oil layers indicate a problem with the separator. If there are coalescent plates, a darkened color indicates that they require removal and cleaning. Catch basin filters also do exactly what their name implies. They are inserted into a catch basin and work to trap and filter out debris and contaminants in stormwater. What they're able to trap and filter depends on the materials they're made of and the size of the holes in the filter material. Common materials include metal, plastic, and specialized fabrics. Materials with larger holes work on debris and contaminants like litter and leaves. Filters with smaller holes can filter things like sediment and sand. Inspection of a catch basin filter starts with the catch basin itself, since damage or problems with the catch basin could cause the filter to be ill-fitting or otherwise inhibit its function. Then check for accumulation of sediment and debris in the filter, particularly if it's inhibiting water flow through the filter. Some filters may need more frequent cleaning than others. Also check for any structural damage to the filter itself and replace as needed. Drywells are the most common underground stormwater facility in Spokane County. Drywells are large, subsurface, cylindrical concrete structures with slotted walls. Water from the surface is routed into the hollow cylinder and infiltrates into the ground through the slots as shown in this diagram. Depending on the application, drywells may be connected to the surface via a catch basin, or it may be open to the surface with its own graded cover. Those connected to a catch basin will still be accessible from the surface through a sealed lid or other structure. Drywells are often used in Spokane County as the overflow structure for surface facilities such as swales or dry detention ponds. Inspection of drywells should always be done from the surface. Check for blockages around the inlet from sediment, litter, or debris, or in winter, check for snow and ice that may be problematic. Check for structural problems at the inlet or drywell lid, including any damage, settling, or misalignment that could disrupt its function. Check for any evidence of illegal dumping. If you do see evidence of illegal dumping, please report this as appropriate. Note that drywell lids can be very heavy. They could be difficult to put back into place properly or retrieved if dropped into the structure. If you do open the inlet or lid, please do so only with the proper equipment and protective gear. Inspect the inside of the drywall from the surface only. Do not climb down into the drywall, and be cautious about slip-trip hazards around the open drywall. If you believe there is a subsurface problem, hire a contractor to inspect the inside of the drywall. From the surface, you can check for the following: floating debris, sediment accumulating above the first row of slots from the bottom, or structural damage to the drywall. When inspecting your stormwater facilities, also note any general conditions and practices in the HOA's common areas that can cause pollution or other stormwater problems. This might include poor waste management, which could be indicated by litter, overflowing or leaking dumpsters, or pet waste in grass or on the sidewalks. Poor car maintenance, which could be indicated by oils, grease, and other car fluids on the pavement, or people washing their cars with detergents near storm drains. Poor watering practices, such as overwatering or watering hard surfaces. Poor landscaping practices, such as piling leaf litter and landscaping debris near storm drains, over-fertilizing, or improperly applying pesticides and herbicides to plants. Poor storage practices, such as storing chemicals, construction materials, or leaking equipment outside in an uncovered or uncontained area. Address any of these problems with residents or contractors as appropriate and as soon as possible. Consider whether there are any ways to avoid problems, such as more frequent dumpster pickups, designated car washing areas, or secondary containment of items being stored outside that may leak. Any of these conditions or practices has the potential to lead to an illicit discharge, which could result in enforcement action or fine if reported or identified during a county inspection. So what is an illicit discharge? An illicit discharge is any discharge to a storm sewer that is not composed entirely of stormwater, which is rain or snowmelt, or any non-stormwater discharges allowed as specified in a permit. Remember the saying, only rain down the drain, to help think about whether something is an illicit discharge or not. Some things are obviously an illicit discharge, such as someone physically pouring chemicals down a storm drain. Other circumstances are not so obvious. One example that often catches people off guard is that dirt, sediment, and grass clippings or other lawn waste that gets transported from a yard into a storm drain is considered an illicit discharge. This is often seen as natural. However, lawn waste, especially in large amounts, can clog our storm sewers, contribute to nutrient and sediment problems, and convey chemical contaminants such as lawn fertilizer and pesticides. Other common sources of illicit discharges are listed. Notice that we covered much of this in the previous slide. The key point is that the contaminants have entered the storm sewer system in order to be an illicit discharge. That is why it is important to be proactive and manage potential contaminant sources appropriately as previously discussed. Always watch for potential problems and respond before an illicit discharge happens. For an example, an accidental spill that is cleaned up properly before it reaches the storm system would not be considered an illicit discharge. There are also discharges that are allowed under certain conditions. Let's clarify. The following are not considered an illicit discharge. Water line and fire hydrant flushing, although this may require dechlorination to 0.1 parts per million or milligrams per liter, where the systems chlorinate potable water. But there are few systems that do this in Spokane County. Pool, spa, and hot tub water when dechlorinated to 0.1 parts per million and allowed to cool if needed. Note that these conditions are not met, the discharge could be considered an illicit discharge. Landscape irrigation if minimized. This means using good watering practices because overwatering or having irrigation misdirected onto hard surfaces could lead to an illicit discharge. Sidewalk, street, and building wash water that does not use detergents. If detergents are used, the soapy water cannot enter the storm drain or it is an illicit discharge. Any air conditioning condensation is not considered an illicit discharge. When it comes to illicit discharges, if you see something, please say something. Report the illicit discharge to either the Washington Department of Ecology or to Spokane County, depending on where the discharge is located. If the discharge is occurring on private property or a private road, please call Ecology's environmental reporting line at 509-329-3400 or use their statewide reporting form. If the discharge is occurring on a public property or public roads, call the county's illicit discharge hotline at 509-477-7525. If you are unsure whether the property is public or private, call Ecology. If needed, they will contact the county. However, if the discharge is due to a gas leak or other hazardous materials, this is an emergency and you should call 911. It does not matter where the discharge is located. As you might have realized, most maintenance for stormwater facilities is relatively simple and serves to ensure proper function. For example, regular maintenance of any stormwater facility may require removing litter, debris, and sediment buildup, or managing the vegetation in and around the facility. In most cases, this does not require special expertise, and HOAs can do the maintenance themselves or utilize their landscaping and maintenance contractor to complete these tasks. HOAs can also organize a cleanup or beautification day to get residents to participate in minor maintenance such as litter pickup or planting. If you are going to complete your own maintenance or utilize residents, you will need to ensure access to the necessary handheld tools and some minimal safety gear. The following is recommended list for a DIY maintenance. Durable pair of working gloves and boots, waterproof or water resistance is always a bonus. Safety gear for working on the road, parking areas, or anywhere there is traffic, including safety vests or other highly visible clothing and traffic cones. A post hole digger or shovel for removing sediment. A wet-dry shop vac for removing sediment. Buckets lined with garbage bags for bagging up litter, debris, and sediment removed from areas. A lid puller for removing a catch basin or drywell lids, and steel-toe boots to protect your feet in case of dropping a lid. However, given drywell lids can be very heavy and difficult to properly put back in place or retrieved if dropped in the structure, you might want to opt for a contractor to handle these structures. Winter conditions require specific consideration for stormwater maintenance. Keep inlet and outlet structures free of snow and ice. Melting snow is stormwater and needs a place to go, or there can be problems with flooding. Do not store plowed snow in swales or ponds unless they are designed to handle it. Since snow often contains dirt and sand, if it is stored in a swale or pond, the meltwater will likely overload the feature with sediment and will need cleaning out in the spring, increasing maintenance costs. Maintain fences and signs for safety at stormwater ponds. Frozen stormwater ponds could be tempting for skating, skiing, or walking on the ice. But stormwater ponds have hazardous ice conditions because the movement of water into the pond and various contaminants cause uneven freezing and thawing of the surface. Use de-icing materials such as salt and sand appropriately. Physically remove snow and ice first to reduce the amount needed. Do not over-apply and sweep up access. Use sand in colder temperatures, such as those below 15 degrees Fahrenheit. This will save you money and improve water quality. Some maintenance activities will require professional contractors. It is recommended to use a professional to inspect and perform maintenance in the following circumstances. Access to and maintenance of underground facilities such as drywells will typically need a contractor due to the requirements for confined spaces, which can be hazardous. You may clean out some storm drain catch basins yourself if they are shallow and can be reached easily by hand tools such as a shovel and shop vac from the surface. Do not climb down into any underground facilities. Contractors should also be used to perform maintenance that requires the use of specialized equipment such as street sweepers or vectoring. Contractors should also complete any major rehabilitation, reconstruction, or replacement of facilities, because many facilities are designed and constructed to specific engineering standards and will likely require specialized materials or equipment. Note that depending on the severity of the problem and how quickly it is addressed, an HOA may need to call an emergency meeting to approve the expenditures for contractors. As with other HOA maintenance costs, it is essential to include stormwater maintenance in any financial planning. A financial plan can help ensure your HOA has the funds to maintain the stormwater facilities and replace them when they have reached the end of their life cycle. The Spokane Regional Stormwater Manual has guidance for the development of a financial plan to cover stormwater facilities. The SRSM example uses a sinking fund calculation to determine the amount of funds needed to be set aside on an annual basis. This calculation considers inflation over the life cycle of each facility and then calculates a cost per lot so that the total cost is shared evenly among the HOA residents. Your HOA's engineering plans may provide information to help determine the life cycle of your facilities and the quantity of any necessary materials for maintenance. If needed, an engineering firm could be hired to assist in the cost estimation. Spokane County has online resources that can help you learn more about your HOA's stormwater. This includes a link to find your HOA plans, inspection and maintenance references, including the Stormwater Management Manual for Eastern Washington, the Spokane Regional Stormwater Manual, an optional inspection form and guidance, and brochures that are homeowners' guides to swales and drywells. Of course, you can always contact county stormwater staff for assistance if you need it. Our phone number and email is shown here on the slide. We thank you for taking the opportunity to go through this HOA training. We hope it was beneficial to you. Thank you very much.